This reaction says I have 1 mole of nitrogen gas reacting with 3 moles of hydrogen gas and forms 2 moles of NH3 or ammonia. This question right down below says how much NH3 could be made if 2 moles of N2 were reacted with 3 moles of H2. How much of my product could I make there, right? If this is my recipe, that's my expectation. How much product can I make? Okay, Claire says 2 moles of my product. Does anyone agree with that? Yeah. Or does anyone have another idea? Anyone think that we could make 4 moles of our product? Okay. Yeah, go ahead, Owen.
So is this like kind of like when you have to put in the sign or like when you?
I would agree that we can only make 2 moles of our product, but why is that? Can you tell me?
Then the 3 moles, like you can't. Just the 3 moles will run out.
That's right. We need 3 moles, and this is exactly what we started with. We started with 2 times as much N2 as we needed. So which one are we going to use up all of? Are we going to use up all of our N2 or are we going to use up all of our H2? We're going to use up all of our H2 because the recipe calls for 3 moles, and that's what I started with. The recipe only calls for 1 mole of N2, yet I started with twice that amount. So what will I have left over of N2? 1 mole, right? Do we see how that works? The production will stop after 2 moles, and then it will just sit. Right? And then it just stops right there. The problem with this is that not all of our questions have nice, pretty round numbers that will line up exactly with our reaction. And so we have to do the stoichiometry to prove it. Okay, that's really what we're going to be working toward. Okay, so let's go ahead and try one here. This is a balanced reaction that says copper plus sulfur is equal to copper sulfide. And I think it's balanced because I see coefficients. But this says, what is the limiting reactant when 82 grams of copper reacts with 25 grams of sulfur? Okay? And it's asking us, what is the maximum mass of copper sulfide that can be formed? So again, I'm going to write those values up here so I can kind of focus in here. I'm starting with 82 grams of copper and 25 grams of sulfur, and I want to know how many grams of copper sulfide I can make. Okay? Now, here's our situation. We cannot do both of these starting amounts in the same T-chart. They can absolutely not go in the same T-chart. I will do a chart. I'll do a stoichiometry problem to find out if I use up all 82 grams, how many grams can I make? And then if I use up instead all 25 grams, how many grams can I make? And then I'll compare at the end. So I have to do the work twice. I have to do both of those charts. Okay, so we're going to go gram to gram, but we're going to take them both to the same product. So let's go ahead and do that. We're going to start with our what we know. 82 grams of copper. Grams of copper to moles of copper. Moles of copper to moles of copper sulfide. And to grams of copper sulfide. So we can go ahead and put in our numbers that go with that. We're going to need molar mass of copper and molar mass of copper sulfide. In this particular problem, there's only one product. So I don't have to make any decisions. But if we run into a reaction that has multiple products, I would need to take both of my starting amounts to the same product to be able to compare. Okay, we'll look at an example of that in just a little bit. But this one only has one product, so I don't have to make any decisions. Right, I'm going to take both of my starting amounts to the same product. So copper's molar mass, I think, is 63.5. 63.5, 1 mole. These mole ratios come from the balanced reaction. And then molar mass of copper sulfide, let's see. about 159? Is that close to what we had? Okay. Okay. Is this about what we had when we ran our math all the way out? I want you to pause there so we can talk through what this stoichiometry is telling us. Okay, tell me if that's not what you got. We're good? Okay. So here's what this chart tells us. This chart tells us nothing about what's happening with sulfur. It tells us if we used up all 82 grams of our copper in the reaction, if we used up all 82 grams, we would be able to form 102.7 grams of our product. That's all we know so far. So I can't answer the question yet because I don't know anything about what happens when when we use up all our sulfur. So now let's do another chart from sulfur to copper sulfide. So 25 grams of sulfur.
I missed what you said. What is the blue chart for?
The blue one is our second starting amount. So now I have to also figure out if I use up all 25 grams, if that's my limiting reactant, how much product can I make? And then I'll compare them to figure out which of them is limiting. But right now I only know half. I know if I used up all 82 grams, I could form 102. So now I've got to answer the question, how much product could I make if sulfur was my limiting reactant? So we're almost giving like a hypothetical for each one. So sulfur's 32, 1 to 1. And we already calculated our molar mass. We get to use it again. Right? The end of our T-chart looks the same because we're going to the same product. So we already calculated the molar mass of copper sulfide. Okay, so is this about what our T-charts look like? Did we do the math correctly? Okay, so now here's how we have to answer the question. This first chart tells me if I use up 82 grams of copper, I'm able to make 102.7 grams. But the other one tells me if I use up all 25 grams, I can make 124 grams of my product. Which do you think then is my limiting reactant? Is it copper or is it sulfur? Copper is my limiting reactant. Good. Now, copper is my limiting reactant because it allows me to make less amounts of my product, right? My production would stop at 102.7 grams. I will not have the opportunity to make 124 grams because copper will run out before that point, right? And so although it says the maximum mass, the reality is that I won't be able to make 124.2 grams of it because by that point, by 102.7 grams, my copper has run out and my reaction has come to a stop. So to answer the question, my limiting reactant is copper and the maximum amount that can be formed is 102.7 grams. So I'm looking for the smaller amount of my product that can be formed because that's when my production stops. Okay, here's what I don't want you to do, and this is a really common thing, is that we do all the work, we answer the problem, and we say, okay, this is my limiting reactant, this one. Is that a limiting reactant? Is copper sulfide a limiting reactant? No, it's not a reactant at all, it's a product. So you're telling me that you understand, but you're also not, right? Because my limiting reactant is found by the reactant that we started with. Right? My limiting reactant is copper, and this is the amount of product I can make. Okay, so don't make the mistake of just circling our problem and saying, nope, there's our limiting reactant. right? That's not exactly how it works, right? You got to show me that you understand it's the reactant we started with that is limiting. So in this case, copper, we started with significantly more grams of copper than we did of sulfur, but it's still the one that's limiting our reaction. It has to deal with how much copper weighs. You needed twice the amount of copper because of the mole ratio. So the way it worked out was that was our limiting reactant. So there's no pattern about its smaller amount, bigger amount to start with, I mean. Okay? All right. What is the limiting reactant when 6 grams of HCl reacts with 5 grams of magnesium? Now, this problem is just asking us for the limiting reactant. It's not asking us about how much product we can make. So I could stop it at moles of my product instead of going all the way to grams if I wanted, right? Because I just want to find the smaller amount that can be produced. I don't have to take my chart all the way to grams. But can I take my chart? I need to go from HCl to a product. Can I take this one to H2 and can I take this one to MgCl2? No. I need to take them to the same product so that I can really understand which one I can produce more of. So I just get to pick which one. It doesn't ask me any extension questions about a particular product. So I can just take them to whichever product I prefer. Okay? And if I'm not having to do grams, it really doesn't matter. If I had to find the mass of one of them, I'd go with H2 because molar mass is really easy to calculate for H2. Right? But I don't have to do that in this one. So let's go ahead. 6 grams of HCl. Oops. And you could go to moles of H2 and you would still get the same limiting reactant as I do, right? The limiting reactant will limit the amount of both products. So you could choose the opposite product and still get the same limiting reactant that I do, okay? Let's put in our numbers here. HCl is 36.5. One mole, 2 moles to 1 mole. But see, do you understand why I can stop at moles? Because I'm just looking for the quantity, right? So I can go ahead and stop there if I want to. If a problem asks me about the mass of my product, then I have to go all the way. Oops. Oh, no, I'm right. Did we remember to keep magnesium at 24.3? Right? That's what I'm like a real stickler about for some reason. 24 is too much rounding, okay? So, tell me which one of my reactants is limiting in this case? HCl. My limiting reactant is HCl. Very good. Okay, does that seem easy enough? Right, because it's a smaller amount of my product. I will stop production after I reach 0.082 moles, and then I can't get to 0.206. I won't have the opportunity to do that. Okay? All right, why don't you try this one on your own? Why don't you try this one on your own? You have to build and balance. Can you believe that? Build and balance, then do the stoichiometry on top of it. Okay? No, you'll just have to do it in some blank space there. Okay. It's a combustion reaction, which means our products are water and carbon dioxide. Okay? And what do we know about oxygen when it's in a reaction by itself? It's diatomic. So is it just O?
It's O2.
It's got to be O2. So when we start to build our reaction, it's got to be C2H4 plus O2. Okay? Why does this, why does this tell me to go to grams of my product here? Because it asks me right here, how many grams of carbon dioxide can be formed? But first we got to build and balance. Build and balance. I've got the data done, but I haven't answered any question yet, right? I still have to take my information and be able to answer the question. So the question says, it doesn't even ask, oh, I guess it does ask me about my limiting reactant. Which one is my limiting reactant? Limiting reactant is O2. And how many grams of carbon dioxide can be formed? What is it? 2.98. Why is it not 15.56? I'm not gonna have enough oxygen to get me to a point where I can make 15.56, right? After 2.98, it stops. My production is done so. Okay? We're gonna try one more here. So we're gonna start with okay, here is our goal. We want to know how much in grams of each product can I make? How many grams of each product can I make? Okay, so this problem is going to make you go from start to finish, and we're going to do it together. But we've got 2 starting amounts, so those are our 2 reactants. So I've got to build and balance with those reactants. We're going to build a double displacement reaction first. Okay, so let's go ahead and do that together. We're going to build a double displacement reaction. So calcium nitrate plus lithium phosphate will yield, okay, what will my products be? Calcium phosphate, so Ca3PO42, and then lithium nitrate. Is that right? My outsides are going to come together, calcium and phosphate, and my insides are going to come together. Do they get to take their subscripts with them from the left to the right? They don't, right? We have to build them from scratch when we put them in as products. So we're going to do that. Now we have to balance. Now we balance. Okay, so I'm going to find an easy change. I see that I need 3 calcium here. That changes my nitrate to how many? 6. That changes my lithium to 6. And so that changes my phosphate to 2. So now I come check it and we're good there. Okay. Did I go too fast on that, or do we feel okay about building and balancing? Okay. Okay, so now we're going to get into the stoichiometry part to find each product. So that means the first thing I have to do is find my limiting reactant, just like I have been. I'm starting with 2.41 moles of this one and 11.46 grams of this one. Now, it asks me for the mass of each of my products. So does it matter which product I go to first? Because I'm going to eventually do both of them, right? So I'm just going to pick which one to go to first. It makes no difference. But I need to take them both to the same product first. Okay, I'm going to take them both to the same product first. So let's go ahead and do that. What's the difference here if I'm starting in moles?
You don't have to do it.
Yeah, it just makes it easier for me. Okay, it just takes out the first step. So I can go directly to the mole ratio step. So moles of calcium nitrate to moles of calcium phosphate. Do we see now why it's so important to keep the compound in the chart? Because otherwise it can get really confusing about which one am I actually looking at and all that kind of stuff. So I'm going to encourage you to still continue to do that. Moles of calcium phosphate to grams calcium phosphate. All right, so I do need mole ratio, which is 3 to 1, and I do need the molar mass of my product. Okay, so go ahead and help me calculate that. I got 310 also.
Yeah, Jackson. You problem.
Okay, so if I go ahead and run out the math there, I can make roughly 249 grams of calcium phosphate. 249 grams. Am I moving too fast, or are we doing okay? Okay, we don't have too much time left, so I want to make sure we get through this problem so we can make sure we understand it, okay? The next part is going to be taking our other reactant, 11.46 grams of lithium phosphate, to the same product, right? Because I want to be able to find which one of these is limiting. They have to go to the same product. So I'm going to go grams of lithium phosphate. Now I have to do the full thing to moles. I didn't get 102. I got 116. I don't know. Tell me about.
Wait, I had 102.
Okay.
31 plus 16 times 4. And 102. How are you rounding yours?
I did 21 plus 31 plus 64.
21.
Don't I have 3 lithiums?
No. Yeah, you do. Wait.
Yeah, you do.
Oh, yeah.
Yeah, that's right.
Yeah, you're right.
Okay. All right, so run that out and see what we get for our mass there. Bless you.
Almost. Almost. That's a big number. 15.3. 3, 1, 2, 1, 3, 7, 8. Yeah, that's a big.
That's what we get when I make up problems off the top of my head. Okay. So these are both grams of calcium phosphate, Ca3PO4 2. So how much of my calcium phosphate can I make? That's one of my products. How much can I make? And my limiting reactant is lithium phosphate. Okay. But my question asks, how much mass of each product can I make? So I've done this one. Now I need to find out how many grams of this I can form. Do I need to do 2 more T-charts to find that out? Or will my limiting reactant be the thing that limits both of my products? It will. Once I know my limiting reactant, I just am only going to work with that from there on out. Right? Once I know my limiting reactant, that's what any future T-chart I have to do, it has to start with that because it will limit the amount of everything. So now I will just start with 11.46 grams lithium phosphate, and I will go to grams of my last product. Okay, I don't need to, I'm done with this chart. The only thing this did was help me determine my limiting reactant. I don't need to do 2 more because it's going to tell me that Li3PO4 is my limiting reactant again. Right, so I don't need to bother doing 2 more. So we already know our molar mass.
And then how much is the weight? 60. Remember that.
No, not for this part. We don't do it for molar mass. Oh, okay. This is funny.
That is not nice.
Whew. Okay. So once I find my limiting reactant, any future conversion I have to do starts with my limiting reactant. Okay, because it's what limits what happens in the whole thing. So my answers here, I want each product. I can make 15 grams of calcium phosphate and 20 grams of lithium nitrate.